good day. I was just watching the drones up in the sky. They're beautiful, aren't they? Today I'm going to be talking more about the rigorous engineering behind drones. A drone is a remote-controlled, pilotless aircraft. It's used for multiple purposes, such as military operations, racing, filming, or even painting a wall. Let's watch. Very interesting indeed. The drone created by the Hero company is a quadricopter hobby drone, made for the fun of flying outdoors for kids and all to enjoy. A quadricopter drone is one which is powered by a lithium-ion battery and propelled by 4 separate propellers, spun by brushless DC motors. This drone has 4 legs or tie rods that connect the battery box to the propellers. The frame is one of the largest and most important components of the drone. It ensures that everything stays rigid whilst taking off or in flight. What the Hero company has done is created a patented one-piece X-frame where the legs are separated by 90 degrees for even distribution by the propellers. This type of frame not only streamlines manufacturing takt times, but also minimizes deflection within the drone. But we'll get on that later. The frame is manufactured using an aluminum 2024 alloy. In order to shape the legs, the aluminum is heated up and forced through an extrusion die. The engineers at the Hero company need to take into account the thermal shrinking of the leg after it's pulled through the die. So, for that case, the die is slightly larger than the diameter of the leg. After the die extrusion process, the legs are then cut into pieces, one 500mm and two 247.5mm. This makes up for the diameter of the initial rod. The cut pieces are then put into a template of the traditional X-frame. They are then resistance welded because conventional welding does not work well with this alloy. And then, after that, out you have the frame we all know and love. Now, let's take a short break to comprehend some of the beautiful engineering behind this drone. Choosing of an alloy is not a simple process. Choosing the right material for your product is essential for your design. Multiple constraints need to be met in order to get the right material for your product. When considering design specifications, the Hero company wants the drone to be robust and magnanimous. For this reason, they designed the individual leg length to be 250mm. This means that the leg-to-leg width would be nearly half a meter wide. On top of this, the Hero company has limited the maximum weight of their drone to be about 1.2 kilograms. This is based off of market research. They want their drone to be fast and agile, giving it a lateral speed of up to 14 meters per second and a vertical speed of 10 meters per second. But, of course, there's more to consider than just static operations. Firstly, when considering a drone taking off, there are multiple forces to be considered. The thrust force of the propellers and the weight force of the actual drone. This difference in forces creates a bending moment and can create resonance when the drone is taking off.
Psst, come here. The resonance factor basically means that when taking off, there's a bending moment between the middle of the body and the propellers. This creates sort of a bouncing effect while in the air and can completely throw off your drone's flight pattern.
To combat this, we need a material with a high stiffness. This means the material will need a high elastic modulus. Secondly, not all drones are perfect, and things don't always go to plan. Engineers must sometimes take into account multiple scenarios in which the frame may experience some unwanted conditions. The most prominent of these being wall collisions. The main forces to consider here are axial and shear forces acting on the drone frame. A material with high strength is considered ideal in this case. A material that plastically deforms under compression would be unideal and would render your drone useless, as symmetry is needed to maintain flight. For these reasons, the aluminum 2024 alloy was selected. It's performed on aircrafts in the past and represents all the ideal qualities that the era company wants for a drone. It's a material that's rigid enough for clean takeoffs and perfect camera stability, as well as being able to take a blunt impact and keep flying. Now, let's get back to the manufacturing process. For this material, heat treatment is done after the frame welding, as resistance welding removes all effects from heat treatment to this alloy. The welded drone frame is then annealed at 900 degrees Fahrenheit and then immediately cold water quenched. It is then age hardened at room temperature. This heat treatment gives the material the perfect amount of ductility to flex upon impacts, but also maintain its rigidity while in flight. Our heat treatment schedule to form aluminum 2024 into the T4 variant will provide the optimal performance because through its heat treatment and natural aging process, it gains a very high Young's modulus, but also the highest durability of any 2024 variant. This means that it has the absolute best fracture toughness possible for its elemental composition. Compared to the other 2000 level aluminium alloys, it has the highest possible shear modulus, which is perfect for handling aggressive flight maneuvers. Extreme shear forces can develop because of the couple created between the drone's center of mass and its thrust points. Its ultimate tensile strength, fatigue strength, and yield strength are also fairly high compared to both other 2000 series alloys and all aluminum alloys in general. In short, it's more than strong enough for an airframe, but also extremely tough to withstand repeated crashes, hard landings, and other abuse without snapping. And rather than a catastrophic failure happening suddenly, aluminum 2024 T4's high ductility means it will start to deform if it experiences stresses outside of its performance envelope. Thus, its overuse can be noticed, the deformation corrected, or the airframe replaced if it has reached the end of its useful life. It's still much easier to replace a drone airframe than to have it break apart in flight. In aerospace terms, undergo RUD or rapid unplanned disassembly and lose the whole drone. Finally, the Hero company decided to use an epoxy primer to counteract aluminum 2024's horrible corrosion resistance. The epoxy primer creates a layer on the aluminum material and creates a passive layer that hinders the electrochemical reaction between metal and water. Thank you for accompanying me on the Hero company's drone frame manufacturing extravaganza. really not.